Welcome back, folks. In this video, we're going to talk about that chicken problem. Just kind of summarize how we can find the equation of the line without actually drawing the graph or writing out the table. Now again, using the graph or the table have their uses. For example, on the graph, it's pretty fast and you get a rough estimate, but it's hard to see exactly where that y-intercept would be. So of course, depending on the scalar graph or how neatly you draw it, you have no idea where this actually is. With the table, it just takes a little bit more time too. So in this video, again, we're going to talk about how we don't actually need either of those. So if we remember our equation in general, the equation for a line is y equals mx plus b. And I guess we should actually talk about this situation first. You saw in the last video, this is the same situation. So we have a chicken that's hatching, and we know that 9 days, oops, sorry about that. 9 days after this chicken was born, it weighs 98.4 grams. So that's definitely important and worth highlighting. We also notice that it gains 5.2 grams every day. So right off the bat, we actually know a little bit of information. We know that it grows 5.2 grams per day. So I'm going to write that down. Grams per day. The reason that it's important to remember the units is because this actually tells you what your x and y variables or your independent and dependent variables are going to be. So when it says something per something, we can write it like this, 5.2 grams per day. And we always remember that our slope is always our change in y over our change in x. This would tell us then that our y, or our dependent variable, is equal to the weight of the chicken. Actually, technically it would be mass. Mass of the chicken in grams. And then x is going to be the days. So we have to kind of keep track of what this actually means. And so the way I'm going to write this out, remember, it grows 5.2 grams every single day. And it makes sense to start recording the days after the chicken hatch. So I'm going to say time after hatching, and I'm going to record that time in days. You could also just say days after hatching. That would be just as fine. So now that I've emphasized, hey, it's the days or the time after it's hatched, when we answer the question, how can we figure out the weight of the chicken on the day? This makes more sense now because the day it was hatched is 0 days after it hatched. And so this would be asking us, what is the y-intercept? Or, in our scenario, what is the weight on day 0? Again, the day it was hatched would be day 0. Okay, so we've talked about what information we have and how it translates mathematically. Notice this again right here is our slope. That's m. And so we actually already know this. This m is 5.2 grams per day. Okay. We want to talk about this equation, so I can actually kind of clean that up. And we know our equation is y equals 5.2x plus b. And again, b, that would be our y-intercept, and therefore what we are looking for. Now this looks kind of awkward because there's a bunch of variables in this red underlined equation here. However, take a look at this. We know that if I wanted to find the weight on, say, day 1, you would just plug in 1 for x. Translates to x equals 1, and then you get a corresponding y out. Y equals something. And likewise, you would plug in day 2, you get x equals 2, and then y would be something else. And so on and so on. But the thing is, what doesn't change? No matter what happens, whatever you plug in, let's pretend we knew the y-intercept. Let's pretend that the y-intercept was just, or the equation was y equals 5.2x plus 7. Well, we know if I want to plug in x equals 1, now I just plug in y equals 5.2 times 1 plus 7. If I wanted to plug in, x equals 2, it'd be 5.2 times 2 plus 7. And so on and so forth. The thing that I'm trying to get at is that what doesn't change. No matter what x and y are, this 5.2, the slope, and the 7, in this case, which is the y-intercept I just made up, are always there. They're always the same. They're constant. And so if I wanted to figure out what that y-intercept actually is, I can just plug in an x and y that I know is on the line. This is where this other piece of information comes in, this first piece. 9 days after the chicken was born, we know it weighs 98.4 grams. Let's see, 9 days after the chicken was born, that would correspond to x equals 9. And the weight, well, the weight we remember was represented by y. And so y equals 98.4. Now, since I know that that information, that point is on the line, I can use my slope and that point to find the y-intercept. So I'll plug in 98.4 equals 5.2 times 9 plus b. With my handy dandy calculator here, because there's a little decimals that make my brain hurt, I got 46.8 plus b. And if I subtract 48 from both sides, sorry, 46.8, and I will get, we should get 51.6 grams for our y-intercept. So we can erase this now, give us some more room. And so our equation then, well, first off, the first question that we asked was, how much does it weigh on day 0? Would be 51.6 grams, again represented by our y-intercept. And the actual equation for the weight of this chicken is y equals 5.2x plus 51.6. Definitely going to want to practice this, but this is a way that we can figure out the equation given the slope, given the slope and a point on the line, even if that point is not the y-intercept. If it is the y-intercept, then yeah, we're just given this part easy peasy. But if not, we can still use that point to find the y-intercept and then create the equation.